gonna try that again. I apologize, folks, if you lost me there. I think it might be the malware that was fighting back, and it didn't want me to identify it, so it just shut down my whole computer. Or maybe that I'm streaming and doing all these things at once. So yeah, let's see here. Um, I'm gonna take a look at something real quickly here. So right now you're getting the side view. Let's see here. Let me fix this up a bit. My CPU is actually not kicking up in terms of usage, so not exactly sure. Okay, so there we go. Better. Okay, there's some rendering lag, maybe. Let's see here. Okay, let me close this. All right, so let's try this again. Let's try this again. So let me open up a few things here. That way we can kind of get back to where we were. And where we started was what we were doing was we had connected to our VM on Azure, and we had created a new project that we were gonna use for training. So we were in the process of installing the SciSharp Redist NuGet package before everything sort of went haywire. Let's take a look here. Okay. And let's go to github.com and stream projects. So let's just go, hey, morning. Thanks for joining. We're doing take two here. My computer crashed a few minutes ago, but it seems like everything should be back up now. Um, by the way, I added it to my profile. If you go to the About page, let me see here. I think I have one. Right, so if you go here, you should be able to see I added. Can I not access it? Where's the About? Come on. It's super slow today. There you go. So there's a stream setup in case you were interested. There's not not really much going on there, but yeah, we can take a look at what's going on there. Yeah, I mean, it seems to be working for me. So, I mean, other than a few minutes ago where it completely crashed, but for the most part, it seems to work okay for me. Let's see here. Okay, so we were doing stamina, and what we are gonna go to here is we want to open Visual Studio Code because eventually we want to connect to our VM that's in Azure. Let's see here. Hopefully this doesn't take too long. Yeah, my CPU is at like 8.6. All right, so I think we're in pretty good shape. Okay. Let's see here. All right. So we're hooked up again here. Let's see. We have these things here. So we have our packages installed. Now, if I go to NuGet, I forget what the name of the package is. NuGet.org. Let's see. TensorFlow. There we go. Perfect. So the one that I want though is 115. And then let's copy that. And let's go to the training console. There we go. All right, and that should add the package to our list of packages here. And let's just give it a bit here. In the meantime, what we can do is .NET restore. Cool. Okay. All right. So now what we're going to want to do is we now know that data drive, train images. Okay. We now know that we have all of our images here. Actually, can I see them? It's fine. So what we want to do now is we want to go ahead and we want to go through the process of loading our images into our an idea view. Hey, Cylinder Kid, thanks for joining the stream. We're going to go through the process of essentially loading our files from disk and loading them into an iData view. Then we're going to go ahead and create our pipeline in ML.NET. That's going to train our deep learning model. And then finally, what we're going to do is we're just going to try that model out and train our model and try it out. So the first thing we want to do is we want to make sure that we're able to load up the files into a list of some sort. So let's see. Data drive, train images, I think it's called. Yeah, okay. So that's that. So let's see. Let image file. Actually, this is not what we want to do. What we want to do is there actually was, if you remember, there is this train labels file. So the train labels file contains the file name along with the label. So if we were to take a look at head 10 train labels, oh, it's in data drive, train labels. Okay, there you go. All right, so this is the ID. This ID column stands for the name of the file, and the class stands for the category of malware or malware family that this file belongs to. Okay, so what we're going to want to do is we're going to want to load from the CSV this information. But remember, we're going to be using the JPEGs, and there's no extension here that's telling it, hey, it's this specific file that we're going to be working with, right? It's this JPEG file that we're going to be working with. Nor does it tell you the full path of the directory, right? So that's something that we're going to have to account for, but that's okay, right? So what we can do is, let's see here. Yep. So what we can do is we can say let image this is equal to, open system.io. Let me actually make this a little bit bigger. That way it's probably easier to see. Okay. Oh, there we go. Okay. Perfect. So let images equal to file.read all lines. Right. And I think we actually created a file here, or created a script that would do that for us. Train files, get the first files, get file specific extension. This is get files directory. No, this isn't it. I could have sworn that we actually built a function somewhere here that was going to allow us to do that. Pad array with zeros, set colors, get image width, get files. Guess not. Okay, no worries. All right, so what we want here is we want to let's get file. And what we want to do is we want to do a directory, and we want, what else do we want? Skip rows. Or has header. Has header. Boolean, and I want this one to be a string. Okay. Now, what are we gonna do here? We're gonna do file files equal to file dot no, this isn't right. Let's see, file dot read all lines, and I want to do that on data dry train labels .csv. Okay, and I also want to do, because it has a header, skip dot or array dot skip 1. Okay, and then what I want to do is I want to do array dot map fun I don't know, row. And what are we going to do here with the row? We're going to do row let calls equal to row dot split, and my separator is going to be comma. Okay, so it's going to be that, and then what I want to do here is I want to create a type where image data is equal to what are we gonna have here? So for our image data, what we want to have is we want to have the image path, which is going to be a string, and we want to have let's call it label, and it's also going to be a string. Let's say it's going to be a string for now. Okay. Now, what we want to get at the end of this is we want to return an image data where image path will equal to row dot 0, and then label is equal to row dot 1, right? That's what we want to do. All right, so let's try this quickly here. Quick and dirty script. System.io, open system file.read all lines, and this is not going to work because that's why. So it's calls, right? Calls not 1. Okay, perfect. Let files equal to this thing. Okay, I went about this the wrong way, but that's okay. All right. So how are we going to do this thing? Okay, there we go. So there are files. Now, this isn't completely accurate because two things we need to do. Number one, we know two things we're going to have to fix here. One is we're going to have to strip the extra quotation marks. And the other thing that we're going to have to do is we are going to have to actually give it A, the extension, and B, the actual directory where this lives, right? So let's go ahead and fix that up a little bit. So let's load files from CSV. don't even know because this isn't loading. This is just I don't know. Get image data. Yeah, sure, we can call it that. And here we're gonna call this the file um, train file name, and then separator extension and then what I want to do is let skip rows file name separator pass header. Okay, so what we're going to do here is we're going to tell it let's skip rows is equal to match has header with true. If it has a header, then 1, false, 0. So skip rows. This is going to be train file name. Okay, separator is going to be this. And what else? Extension. It's going to be let's see. Let image path equal to train. Okay. Data directory. Data there. Okay. So image path, it's going to be equal to printf, and then it's going to be %s slash %s dot %s, right? And the 3 inputs that we're going to have is going to be the data directory, the row dot 0, and it's going to cols dot 0, right? And we want to have also the extension, right? So ext. Perfect. All right, let's try this out for now and see what it looks like. So let's go back here, get image data. So what's this going to look like? It's going to be get image data, and what else comes here? Train file name. So it's going to be data drive slash train labels.csv. Okay, so that's that. Then my separator, I want it to be a comma separator. I want this to be a JPG, right? Oh, has header. True. What's going on here? Expected to have type character array, but here has car. No. Okay, perfect. So true JPEG has header, data directory. It's gonna be in data drive, train images, and then finally, whoops. So it's has header, data directory, and extension. Okay, let's see what this cooks up. Okay, expects to have type car type and is right, because I didn't reevaluate this. So now we know that it's a character. Boom. That's not exactly what I was. Oh, because I forgot to change this here to now use this image path that we created. Let's go ahead and reevaluate this. And then let's run this. Okay. Perfect. Data drive, train images. Almost there. Now we just need to get rid of the extra quotation marks. Let's see. How do we get rid of these extra quotation marks? Okay, let's see. Trim should do it. Yeah, you're right. Let's see. Let's trimmed file name is equal to cols dot so cols dot 0 dot trim. But there's a visual called Synthwave 84 that's so complimentary, cool neon background. Yeah, I think. Let me see. Color theme. Oh, that's not the one. I do have it in my. I do have it in my other. I think my Mac. I got it. Yeah, I know which one you're talking about. Let's see. Is it this one? Yeah, this is it. This is the one, right? The VS Code theme. Let's see here. Oh, reload. Let's do it. Oh man, but you know what? I think this is gonna do it on my that no worries. It's gonna do it on my remote machine, not on my let's see. There we go. Yeah, I have this one on my Mac. Yeah, no. Thanks for letting me know. Yeah, no, absolutely. I actually have it. Like I said, I have it on my Mac, not on this PC here. And yeah, it's really cool. Yeah, no, yeah, we kind of do that on stream, right? Like sometimes we'll just talk about other things, and we learn in the process. But yeah, no, thanks for letting me know, and it does look way cooler. Trim. Where is this? No, it's calls dot 0 dot. Why is it not showing up? It should just be trim, right? Let's see. When in doubt, go to the .NET FSI. So if I have this, right, like test dot trim, yeah, I should just be able to do that. So why is IntelliSense not popping up here? String array. Yeah, what I'm trying to figure out here is why like the IntelliSense is not popping up for me. Like it should tell me, because this is a string, that I should be able to trim. Yeah, so for example, if we had this and then oh no, what'd I do? All right, let's see. So you're saying this, right? Let's see. Dot trim. But I can't try this out because .NET FSI. So if I were to have something like test dot trim. There we go. Okay, cool. Yeah. Yeah, I don't know why the IntelliSense isn't telling me. Like, if it knows that it's a string, like this is a string, why is IntelliSense not popping up? All right, but we saw that that worked, so let's go with this. And instead of this, we're gonna call it trim find name. Okay, and if we let me quit this. Let's go back from the top. All right, boom. Beautiful, 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 beautiful. All right, so let's make it part of our script. So we're gonna go here. Whoops. So type image data. Just make sure that I got this. And we are not in app. I want it in program.fs here. Okay. Okay, and we want to open system.io. And along the way, let's make the CLI mutable. So when you're working with records inside of, when you're working with records with ML.NET, you got to make sure that it's CLI mutable, all right? Because by default, records are immutable. So yeah, you just kind of got to make it CLI mutable. And then let's see, opens Microsoft.ml, open Microsoft.ml.vision, and I think the image, no. Let's go with this for now. Okay, so what's the first thing we do when we are building an ML.NET application is we start with the context. So let ctx equals ML context. Okay. Now the same thing, the next thing that we want to do is want to load our file into an iData view. Let idv is equal to, well, first of all, let image data is equal to, let's grab this here because we now know what we need to call, right? So data drive, true, JPEG. Yep. And actually, just to make sure here that this is accurate, let me do something here. List dot, what is it? List dot length. And there should be 10,868 image data. Okay, so it's not a, it's an array. Array. Perfect, 10,868. Okay, good. That's exactly what we have. Okay. So image data. Now what we want to do is we want to load. So let idv image idv is equal to test. What is it? Test data. Image data. No. ctx dot data dot load from enumerable image data. Okay. Yep, this is all I need. So now that I have this, now I have it into a data view, it's time to create a pipeline. So this is load data into iData view. And then we're gonna create a create pipeline. Okay, so what is this pipeline gonna look like? It's gonna say let pre-processing pipeline is equal to estimator chain dot append no ctx dot transforms dot load images. And what does this look like? Simple and binding. Please complete structure before this point. New estimator chain. Okay. Interesting. I forget how to do these from time to time. Because, so the way that you do this in, the way that you do this in ML.NET, sorry, with C# is different than you would with F#. So good thing that I sometimes like to write things down. Okay, so it's just estimator chain. No new, just regular estimator chain. Okay. What? Append. Am I missing something? Let's see. Pretty sure I'm missing an import somewhere. Maybe this one? Okay, fine. So append ctx dot transforms dot load images. And this one, the optical name is image. Input column name is going to be what? Image path. No. Okay. So what this is going to do is it's going to take, did you add TensorFlow package while VS Code was open? I did. Do you mean this one, the Redist? Yeah. So the TensorFlow package, I did add it, and that was like at the very beginning when I was importing everything. But I don't think I needed that to get this going here, the estimator chain. That's part of ML.NET. For on this on the trim, is that what you're referring to? Oh, you're saying that I didn't do like a restore or something like that? Yeah, it's possible. It's possible. Let's see. Okay, so once I load the files, what do I want to do? Append ctx trainer dot multi-class classification dot image class dot trainers dot image classification. Okay. Now what I'm gonna do though is I want to have trainer options, right? So, well, there's literally nothing here. Pre-processing pipeline. And the other thing that I want to do is I want to, I think it shouldn't be too bad. I just saw it happening for me from time to time. Yeah. Sometimes it will happen where it's if you don't restore it or something like that, it automatically gives like it's hard to deal with. But yeah, I mean, it seems to be back now, so at least that's good. And also I remember like last week I was having some trouble with the F# interactive and getting IntelliSense to work there, and the reason for that was you need to let the compiler you need to set in the settings, right? You need to set fsac runtime to use .NET Core instead of .NET Framework. So that's kind of the problem that I was having with IntelliSense last week. But since then, as you notice, like I'm able to, for the most part, take advantage of IntelliSense now inside of the interactive or script files as well. Let's see here. Okay, so now that I did append ctx, that transforms transforms dot um, convert dot map value to key, and the one I want to map here is the label. Okay, and that's it, right? Like, I just want to pre-process this like that way. What else am I doing here? So create training pipe. Excuse me. So let training pipe, let trainer option. So before I even do that, let me do this, and this is gonna be new image classification dot options. Let me see here. Dot options. Okay, and what are the image classification options? Trainer dot options. Is it new? No, I think it's... Okay, what's the problem here? Okay, usage is redundant. Okay. Let's not be redundant. At least one field. Okay. So let's go and take a look at the documentation. Image classification trainer options ML.net. Okay. So what are we gonna do? So for one thing, we want to use the for the architecture, we want to use arch is equal to dot. I don't know which one they used in the paper. Let's see if it says it. So if we go to the app here and we go to scalable white paper, I don't think it mentions which architecture they used. Let's see, static malware analysis, into labs, deploy stamina steps, resizing, dynamic analysis, pre-processing. That's not what I care about. Transfer learning step. Okay, so it's something that was trained on ImageNet. Okay, that's nice that you're telling me how transfer learning works, but what I really want to know is which architect. Oh, ResNet, such as Inception or ResNet. Okay, so we can go with Inception or ResNet. Sure, let's do Inception. What else are we doing here? Arch. Why is it not Arch? Okay, let's see. Trainer. Let me see. I did this a while back, but I forgot how you can set the options here. So F# getting started. TensorFlow training. Yep, this is it. Yes. Okay, train program. Oh, is that what I have to do? Ugh, that's not nice. Trainer options. Mm. Trainer, no, this is it. Trainer options dot arch. And then I gotta do classification trainer dot architecture dot exception v3. There we go. So let's go with this for now. Boom. See, that's why like sometimes like it's so good to document what you do, or like have something out there, because I completely forgot how to do this, but I know that I did this like, what is it, 4 months ago. So yeah. All right. So yeah, let's call it label as key. Sure. Just so that we're explicit. Yeah. Let's see. And I don't want to have RESTnet. I want inception. Is there anything else that I want to do? Trainer options dot. I don't care about the batch size. I don't really care, or do I care about the epics? Um, I don't care about that. I don't care about that. Reuse train test on train set. Let me look at the options and what the defaults are. Test, what is it? Test on train set indicates set to true by default. Test on train set. Okay, yeah, we're gonna do that. Train set bottleneck, validation set, workspace path. Workspace path. Um, let's see here. Workspace. And let me add something here just in case it doesn't exist. Call workspace. And the reason why we need this workspace, so kind of like taking a little bit of a step back, right? So what we're doing here in this pre-processing pipeline, we're telling it load images, and it's going to look at our image path here, right? It's going to look at our image path, and what it's going to do is it's going to load, I believe it does it as a bitmap into a new column called image, okay? And in this map value to key, what it's going to do is it's going to sort of create like a dictionary that contains, in this case, if we remember right, the labels, along with, it's going to have some sort of mapping between like label 1 is equal to this particular key value pair, right? So it's going to have key value pairs for these labels, right? So that's for our pre-processing. Now for the for our training pipeline, or selecting our classifier, what we're doing here is we're telling it we want you to use the Inception v3 architecture to train this deep learning model. We want you to look at the image, right? That's going to be your input, and the category that we're going to be trying to classify, or the value that we're going to be trying to predict, is this labeled as key value, right? Um, Now, workspace path, what the workspace path gives you is, so if I go here back to the paper, right? There, so when you're doing transfer learning, there is sort of all of the layers that let you see they kind of let you see at a granular level what different features about your images, right? Like, is there a rounded corner here? Is there like a sharp, sort of diagonal line that's going through it, right? So these first set of layers, that's what they allow you to do. They allow you to tease out individual sort of features about images, right? And in these last layers, that's where these smaller features sort of become bigger features. So, for example, if you're recognizing a face, these later layers are the ones that are kind of determining, like, is there a nose? Are there eyes? Is there a mouth? Are there ears? Things like that, right? And with transfer learning, what we're doing is we are retraining this last layer, because essentially, if we're looking at a picture, it's going to have edges, and it's going to have rounded corners, and it's going to have all these small features that, again, are going to define things within an image. But what we really care about is the higher level concepts, right? That are presented in these last set of layers. Now, if if the values that are so as you're doing like sort of like a as you're passing data through these layers, right? Because they don't change and you're not retraining it, it's a one shot type of thing where you're just telling it, hey, uh, calculate the values from input all the way to this layer, right, or to previous to this the layers that we're going to be retraining, right? And as a result, right, what you want to do is you want to be able to cache those, right? Because it's a one-time thing, it's a one-time operation. You don't want to have to like recalculate those, so you want to be able to cache them, right? So that later, when you want to go back and you want to say, okay, well, what's the values when you want to retrain the model or something like that, you already know what until this step what the value should be, so you can then leverage the cache values rather than having to like go through the process again. So this is kind of what's known as the bottleneck phase, right? So, or the bottleneck layers or the bottleneck phase, and it's a one-time calculation, right? Um, Depending on the architecture that is as well, right? Because if I change the architecture, obviously like the layers are going to look differently, this first set of layers, so I'm going to have to recalculate. So assuming that you're using the same layer to retrain, and maybe you're changing the number of epochs, or you're changing the number of the learning rate, things like that, hyperparameters, right? You're doing hyperparameter tuning, but still within the same architecture, you don't want to have to go back and recalculate these things, right? So locally. So the compute is actually going to be happening on Azure. So this thing here, this is a VM on, as you can see, SSH, whatever. It's on Azure. It's actually a pretty low power device. So I'm actually interested to see how it's gonna do. I think it's got like 4 gigs of RAM. Um, so I suspect that it's not gonna perform very well. But if I leave it training sort of, overnight, after we kind of set up the process, set up the pipelines here, I suspect it will be done overnight. But of course, it's not going to be the fastest process, right? But that's one of the nice things about Azure, right? So like at the end of the day, like all this is, it's just it's just a VM on Azure. So the nice thing about that is, we have a drive, and that's where all of our data is stored, right? There's this disk where our data is stored. So because on Azure and like most cloud computing environments, your compute is sort of separate from your storage. What I could do is I can say, hey, I want to scale this up to like whatever 32. Exactly. Yep, it's an app service, and you can scale it up, right? So in this case, I have four gigs of RAM, which is certainly not going to train, within the next half an hour, or hour, even for that matter, right? But I can just go to Azure and click, hey, scale this up, and it's going to give me a new compute with more capacity behind it, right? And I could still leverage the disk where I have all my data stored, and we can rerun this process um, in very much the same way, or rerun this script in very much the same way. So let's see here. Yeah. So essentially, again, that workspace path, that's exactly what this is doing. It's it's just storing the cache values. Okay. So now that we have this, now we can just say let's trainer pipeline is equal to yeah. There's a lot of really good um and affordable ways for you to get started on Azure. The cognitive services, they're very how can I say this? Um, like they allow you to experiment, and they allow you to sort of to go beyond getting started, right? Like it's not like, oh, you have three, you can only make 3 requests and then that's it, right? No, like I think there's a few thousand, and if you're processing a few thousand requests, then that's a pretty robust system that's probably running in some sort of production. Maybe not like a large at scale deployment, but a few thousand requests. That's significant, right? And yeah, it's really cool that you could test like, hey, how would this work in a sort of like a very low scale type of environment, but it's at least sort of piloting and mimicking that what that production environment might look like. And again, going back to that initial sort of topic, or what we were talking about earlier, is like if you want to scale, right, that's like an easy problem to solve. You literally just go and click like, hey, I want to scale to X tier, right? And I can then just, you know, with a few clicks, be in a larger scale uh, sort of production environment. Yeah, yeah, it's right, exactly. Yeah, for a free service, it's fine. Yeah, it's been a while since I've actually tinkered with the bot framework and with Lewis. But I keep seeing every time that there's a lot of great features, a lot of capabilities that are built in. So at some point, I might want to dig back in and sort of try to build something. But yeah, no, there's a lot of really cool stuff. And the other nice thing is, I think you can do it with Lewis, where some of these services, you can essentially run them. I don't want to say offline, but you can run them in your data centers, right? Because you can run it as a container. You can take it and you can run it inside of your own data centers. And the only thing that's really communicating to the outside world, you still need some sort of internet connection, though not like a constant one. And you just need it to kind of ping and for billing purposes, basically, right? It's like, okay, well, you've used X amount of calls inside of your container service, and just ping, this is the usage amount. So that's kind of how you're getting billed, right? But yeah, it's really neat what they can do. Let's see. Am I doing another estimator chain here? Yeah, you can use your own compute. So that's a really nice thing, right? So if you don't want to be sending the data to over the wire, right? I mean, it's going to still be going over some wire. It's just now it's going to be going over your wires versus sending them over sort of a public, uh, sort of the public network to Azure, right? You can take advantage of the Lewis models, but inside of your own data center. So yeah, it's really cool. No, multi-class image classification. Okay. And then one last thing that I want to do here is I want to say let post processing pipeline is equal to ctx dot what dot what are you complaining about? It's unfinished. I don't like that, but let's see. Dot. What are you complaining about? Don't tell me I have to wrap this as an estimator chain. Let's see, how did I do this here? I do have to write it as estimator chain. I really don't know what you're complaining about, but you screw up the indentation somehow. What's going on in IntelliSense? All right, what? Conversion dot. All right, we're gonna kind of fly blind a little bit here. Map key to value. And we're going to kind of hope that this works. So CTX, that transfers that conversion. Okay, and we're going to take the output column is going to be predicted label. Okay, good enough. All right, so let me go to bash here, .NET restore. There's shred further up in your code. Yeah, there's I don't know why the entry point here is why this is becoming a problem. Let's see, because if I bet you that if I do this, then there we go. So there's the indentation. So the indentation was throwing that off, but what's throwing this off? Yeah, so there's no error here anymore. But what's the problem here? This value is unused. Okay, fine. What is it? Incomplete value or definition. This is an expression. The body of system must be indented. Same column as the let. Yeah, but this is literally what I have here. So I don't get. Okay. Okay, and what are you complaining about now? Let's see here. Yeah, well, I mean, yeah, I mean, this is like I don't think this is about the code at this point. I think that this is it's got to have something to do with the indentation. Let me see how I did it here. Pre-processing. Yes, your thing here. Let's training. Yeah, like there's trainer options, workspace path, workspace. Okay. I mean, I don't. There's no semicolon here. So there's like nothing or no reason. All right, this got to be some sort of joke. How come it's not like okay? So it's not complaining now. Let's post processing pipeline. So what I'm doing now is yeah, yeah. I literally have no idea what wasn't working. Like, yeah, I don't know. Let's see, conversion dot. So now we're going the other way, right? So now that we've got a model, if you recall here, what we did was we took the label, the string value, and we converted it into a key value pair. Now what we're going to do is take the key value pair and convert it back to its original value. So that's what we're doing here. So map key to value. And then by default, we're going to get this column called predicted label, and that's what we're going to want to put this on. So let pipeline is equal to um, pre-processing pipeline dot append training pipeline dot append post processing pipeline. Okay. All right. So now we got our pipeline. Last step, and white space on the line below. Working in Python is always showing white space at all time. Yeah, yeah, it could be the white space. Like this, these are always kind of like the catch, you know, the things that always sort of get you right. It's nice that you can be succinct and stuff like that, but sometimes the white space will come and sort of haunt you. Yeah, I have no idea what the problem was there. I mean, it seems it's literally the same code. It's just yeah, I don't know. Okay, so now that we have our pipeline model equal to what do we call it? Image IDV. Pipeline dot fit. All right. So there's that. Um, I wonder if I have to, because I think otherwise it's not gonna do anything. Um, I think it's not gonna do anything. So I think by default it doesn't print anything out. So I think I want to have it print something out to the console. That way it's giving me feedback on what's going on. Whoops. Um, so trainer options, metrics callback, and I want it to be x print percent x to string. Yep, good enough. All right, so what we're gonna do at this point now is, now that we have a pipeline, first let me make sure that it builds. Everything builds. And I hope that it works. Building, 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 building. Mm-mm-mm. Taking a while there. Training console. All right, so while that's going, let's open up our trusty. Oh, I'm not even training right now. I'm just building. I'm literally just building the project, so I have no idea why it's taking so long. There we go. So what we're going to do is, because it's going to take forever to train, and I'm coming up on the half hour here at 11:30, what I am going to do is I'm going to, kind of like we did last time. Last week, when we were processing data, we knew that it was going to take a while, and we were just going to let it kind of like do its thing. I'm going to set up a tmux session for training our model. That way we can just let it run, and we don't have to worry about sort of timing out or any weird stuff happening. So tmux ls process files tmux new session, and we're going to call it train model. Okay. And what we're going to do here is we're going to go to stream projects. We're going to go to stamina. See, train console, .NET build. And I suspect that it's going to take a while to train. But yes, it is going to take a while to train. And fingers crossed that this is going to work. .NET run. Let me just make one last. Okay, data drive, train labels, train images. JPEG. Let me just make sure one thing here. Last train data drive. Okay, JPG. Okay. Okay. Oh, let me save the model because I don't want to go through the process of training the model but not saving it. So model dot save ctx dot model dot save ml model dot zip image dot schema Whoops, I got these wrong. This goes here, and this goes here. All right. All right, good enough. Let's build it once more. .NET build. .NET run. And if it starts training... what happened? Schema mismatch for feature column. Var vector got image. Argument out of range. Schema mismatch for feature column image. Expected var vector byte got image. Oh, yeah. I think, how did I do it here? I think I told it to load raw image bytes. Yeah, load raw image bytes. Load raw image bytes. So the reason why that happened was I told it the image bitmap, but it won't take a bitmap. It needs bytes, right? So load raw image bytes is the kind of, I don't want to say overload, but it kind of does the same thing. It loads the images, except it loads the bytes instead of the images themselves. So let's go here and let's try it again. .NET run. And what's going to happen now is the model is going to download to our PC. Once we have downloaded our model, okay, there it is, CPU. No. What happened? Could not find file, train images. I thought we had fixed that. So it's telling me it can't find the images, but I thought we had fixed the stripping issue. Let's see here. Get rid of you here. Do I have a sharp? Yep, I have a sharp interactive here. So just to make sure that I'm on the right path here. Wait a minute. We had fixed this. We literally had just fixed this. Maybe I messed up and did like a Control Z by mistake. Yeah, there it is. Okay. I have no idea what happened there. But no worries. We can just do this. Boom. All right. Perfect. Right. So good. Build and .NET run. All right. As soon as I see it starting to, there we go. Training images. Oh, nice. All right, we're training. So there are 10,000 images. So this could take a while. It's actually going faster than I thought, though. But I won't make you sit here through this. So this is as good time as any to end the stream. We can come back. So I'll come back on Wednesday, same time, 10 a.m. Eastern. And we'll see whether our model has trained. But in the meantime, it's looking good. It's looking promising. So again, thanks for joining. And I hope that you had fun on stream. I know I certainly did. Yeah, it's really taking shape. I'm really happy with what we got so far. It's only taken like a month to build this. Slow, but this piece, right? It's one of the really nice things that I like about ML.NET, right? Like if you had to do this using, like actually going into TensorFlow and trying to build your own model, it would be significantly more lines of code than what we've written here. Here it's 71, including the loading the data, and just making sure that you have the right transforms built in. So in under 100 lines of code, we've got ourselves, this mechanism that's going to be able to allow us to identify malware using deep learning. So I think that's pretty cool. But yeah, again, thanks for joining, and I will see you on Wednesday. Talk to you later. Bye.